right, we have the Math 1113 Zoom meeting for today, October 16th. And today we're covering section 6.3, 6.4, and it shouldn't be that difficult. It is about graphing. 6.3, we are graphing y equals sine x generically and cosine x curves. And 6.4, it is the other four. Graphing y equals tangent, cotangent, secant, cosecant. So they separate them off because these look distinctly different. But they're grouped, similar things are grouped together, except tangent and cotangent is distinctly different from secant, cosecant. All right, and the generic for 6.3, the generic formula page 526, y equals a sine of a k and x minus b. Now, I like to add on, I'll call it VS, vertical shift. Any number added on is a vertical shift. The book doesn't do that. All right. And it's the same thing for cosine. Y equals a cosine k x minus b plus, I like to add on vertical shift. I like to add on. If it's negative, it's down. Positive, it's up. Negative, it's down. So I'm getting this from this box, and it gives you three things, but they do show you some vertical shifts. I don't know why they don't put them in here. Okay. A, or the first thing, they call it amplitude, is the absolute value of the A, this coefficient in front that's multiplying. On the graph, generically, this is a generic sine graph, and cosine starts high and goes around. I think I tried to explain this just a little bit, why this is at one point. But A is the distance from the center up, distance from center to peak. Second thing they want is called period, and it is the time, you could say the time for one cycle, or the time to repeat. And period, no great symbol for it, is 2 pi divided by this k, generically here. Number 3 is the horizontal shift. It's otherwise known as phase shift. These kind of terms, amplitude, if you probably never listened to AM radio, but AM radio is amplitude modulation. And it turns out these are waves. You can put meters on these electrical signals coming out of your radio, and you will see waves like this. And your voice is carried by modulating this amplitude. I have to go take further classes in electrical engineering to learn all about this. But in any case, this is the generic, very basics of it. And the phase shift, horizontal phase shift written in this form is just equal to B. Notice that once again, just like a circle or just like a parabola, at least on the x-coordinate parabola, the formula shows a minus, but your B is positive. All right, so we'll work a couple examples here. You can graph these on the calculator. They start off, I don't know if I'll do any of the simple ones or not. They start off actually just graphing 5 to 18. You can just graph the function, enter it on the calculator. Make sure you want radian mode. See, number 5 has a vertical shift. You're shifted up 2. So does 15. All right, then they want just the first two things in 19 to 23, just amplitude period and sketch graph. And then they finally want the whole thing, amplitude period, horizontal shift, and graph. You can copy the graph off the calculator. All right, so I think maybe I'll just do a couple of the whole thing, and hopefully you'll get it for the simpler ones. So let's try page 531. We're in section 6.3. Problem 33. Graph y equals cosine of an x minus pi over 2. And the worksheet has the amplitude, period, a horizontal shift, and finally the graph. Of course, you can do the graph first, right off the calculator. You want radian mode. Well, the amplitude is the number in front, the A value here. With no number, it would just be 1. The amplitude would equal 1. Period is 2 pi divided by the K value. The K value is the coefficient in here. Again, no number, that would be 1. 2 pi. It repeats every 2 pi. The horizontal shift would simply be a pi over 2. In other words, I'm matching to, right out here, y is cosine of x minus pi over 2, and I'm matching to a cosine of k x minus pi over 2. So you can see a is 1, the k is 1, and the b, which is the horizontal shift, is pi over 2. So if we actually draw a graph, you don't really have to worry about what they're saying about one complete period. We can just pretty much enter it on the calculator and draw the graph. Make sure I'm in radian mode. Y equals, and we want cosine x minus pi divided by 2. You can pretty much keep your standard window. Back negative 10, 10, 1, negative 10, 10, 1, negative 10, 10, 1. And yeah, it's kind of, now I said a cosine kind of starts high at the y-axis. That's a pure cosine. This thing has been shifted. It actually looks like a sine. So this one is going up and down through the origin. It's really a shifted forward cosine. Shifted forward cosine becomes a sine. You get the same numbers out of the formulas. The distance up from this is 1. It's the amplitude. Your period here to, no, sorry, not there. Here is 2 pi. That's your period. Amplitude equals 1. This is from center up. Off the sheet, sorry. So yeah, your period from here to here is 2 pi. Generally pick a nice start point, and then on the same upslope, you go through the center back here, but it's on the downslope. So you want the same upslope. It's your period of 2 pi. Your amplitude is 1. And your your shift is pi over 2. That is shifted from a pure cosine. Cosine of x goes through the y-axis there, and this has been shifted pi over 2. In effect, the pi over 2 is the shift from this peak back. That is your horizontal shift. All right, now that one was set right up to pretty much match exactly. So why don't we try one that's a little trickier? Problem 41. Problem 41. Y equals 1/2 minus 1/2 cosine 2x minus pi over 3. All right, fill in the worksheet. Amplitude, period, horizontal shift, and graph. All right. Notice this is vertical shift. Didn't really ask for it. The amplitude here is going to be 1/2 positive. That will be that, 1/2. All right. Period. This is the K number. 2 pi over 2. This will be equal to pi. Repeats every pi. The horizontal shift is what gets tricky. If you will notice, back to the formulas. For horizontal shift of this B, this K is factored out. So I'm going to bring it down here. Y 1/2 minus 1/2 cosine of 2, and then x minus pi over 3. The horizontal shift is not pi over 3 because you got a 2x. You got to match 2. A, we'll ignore the vertical shift, cosine of k, and then a plane x minus b. K is the 2. We got to factor out the 2. So that's a cosine of 2 parentheses x. So I'm factoring out the 2 as the k right here, minus pi over 3. But you see, I got to be able to multiply the 2 back. If I do it just like this, I'd get a 2 pi over 3. Not the 2's got to divide down here. So I get a 2x, and then 2's cancel, leaving the pi over 3. So I get an a cosine of 2, and then an x minus pi over 6. Now that matches your k is 2, and the b is pi over 6. That's your horizontal shift. Horizontal shift is pi over 6. Finally, if you want to number these, 1, 2, 3, finally 4 for a graph. You might want to change. This is going to look pretty tiny if you stick to -10, 10, 1. I'll stick to that, show you how bad it looks. You're going to have one, how we use 0.5, and you're going to subtract 0.5 cosine 2x minus pi divided by 3. Graph. You barely see it. Notice it's up above the x-axis, which means it's been shifted up 1/2. Let's window it down. The x is okay. You see a lot of cycles there. Let's let's go 0 basically to 1. 5, say. Well, that really, you can really play around. Basically 1/2 right through there. it's going down through that center there. So a half, 1. It's going down through that a half. It's hitting the x-axis and curling up and down up to 1. It does not go above 1. Bad. It should look uniform. Tough to draw by hand. Not an artist. It does look uniform. You don't have to label the things on the graph, but just to show you your amplitude, that distance from that center up is a half. That's your amplitude. Okay. Your vertical shift is a half, even though it didn't ask for it. All right. Your distance, you're going down through the, usually track it from the y-axis on the down slope. So over to here. So from here to here, that's pi, your period. And you've been shifted horizontally pi over 6. All right, I'm going to match the answers in the book. 6, 3, 41. Okay, they just give you the 3 numbers, labeled pretty sparsely. A half is your amplitude, pi was your period, and pi over 6 is your horizontal shift. And they're not drawing really what you see. They're doing that one period stuff started from here. You don't have to worry about that. You just give me a graph that's off the calculator. That's about all there is to it. 6.3, that's the stuff they want to know. 6.4 is again the other 4 graphs. The other 4 graphs. I'm going to start with secant and cosecant. And there's going to be minimal information we want off of these. I'll start with cosecant and secant. Okay. Minimal info we want is just period. Is just period. And it's the same thing as sine and cosine. It's 2 pi over the k. All right, with no amplitude, you're going to see why in a minute. No horizontal shift. Not going to mess with it. Okay. 6.4. Just make sure that yeah, not going to. I avoided this section with horizontal shift. No point in messing with it. All right, start with, to explain what's going on here, y equals a straight sine of x. I'm going to graph it. Sine of x. No. We'll collapse so you can see a little better. Let's collapse -2 to 2. All right, you can see a straight sine of x going up and down. I'm going to dash it because we really want the cosecant. Okay. We want cosecant of x. That is 1 divided by sine of x. Now, the easiest way to explain this is look at the x-axis. At this point, sine x equals 0. cosecant of x would be 1 over sine, which is 1 over 0 at those points, at every one of those x-intercepts points. Which is undefined. And gives a vertical asymptote. So the easiest way to draw a cosecant is to draw the corresponding sine curve. I'll write this out as step 1. To graph cosecant, graph straight sine curve, draw vertical asymptotes. Through the x-intercepts. Now, at peaks and dips, at the peak, sine x equals 1. Cosecant 1 over sine is 1 over 1, which is 1. So these peaks are identical on both curves. Down here, you've got sine x is negative 1. You're going between -1 and 1. So your cosecant is still negative 1. Cosecant is still negative 1. Flip negative 1, you get negative 1. And then what happens is when you flip these things, like at some point you're going to hit a half. Well, 1 over 1/2 flips up to 2. So a 1/2 point flips up to 2. Right up here, you flip up and you get a u that's bounded by these vertical asymptotes. Down here, it flips down. Over here, again, x-intercept there, and this peak flips up. Over here, you flick down. Your dip flips down and your peak flips up. Show you that on the calculator. So keep the sign so you can see how they're matched, and there's no cosecant key. So you got 1 divided by, not x, sine of x. Graph. So your sine is still there. Now notice how every peak flips up, every dip flips down. They're not, the calculator doesn't show you the vertical asymptote that runs right through that x-intercept. Those things, there's a vertical line right through those x-intercepts. The actual cosecant are these u's. Opening up there and opening down there. But it's easiest to line them up and match them if you match them with the corresponding sine curve. And by the way, this works the same for the cosine. The same idea. And then you can say flip the peaks up. Or in effect, I like to say flip the humps. Up humps flip up, down humps flip down. Let's try one out of the book. .4, page 540. Why don't we try a problem 17. Graph 3 secant x. Number 1, I'm going to graph y equals 3 cosine. Cosine x. Oops, should have done up here. 3 cosine x. Clear that off. Okay, the amplitude on that one is 3. So it's a little big for the thing. Okay, why don't we go -3, 3. Okay, there you are. So it's a straight cosine with the amplitude of 3. Now I'm going to dash it. Goes up to 3. It goes down to -3. Okay. Y equals 3 secant is 3 times 1 over cosine. 3 over cosine. You can argue it out without even punching it in a calculator. At every x-intercept, you get a vertical asymptote because your cosine would be 0. Oops. Your peaks are at 1 and they flip up, and your dips are at -1 and they flip down, and the curves are identical because when you flip one to -1, they don't change. Okay, here, and so flips down, here flips up. And you can see that to see, I have to extend the y range. Let's go back to -10, 10. So use 1. So there's your center cosine. I didn't enter the secant. Sorry about that. So I basically enter at 3 divided by cosine x. So there's your center. And now you can see all the flipping up, the hump flipping up, the dip flipping down, etc. Between vertical asymptotes that flow right through the x-intercepts. Calculator doesn't draw the vertical asymptotes. And so all they want is period, and it's identical. When you flip these things, they repeat exactly like your cosine. Once again, 2 pi over k. K happens to be 1. It's just straight 2 pi on this one. That's all they want. You see why there's no amplitude. These go up forever. So an amplitude implies there's a limiting value you never get beyond. There is for cosine and sine in the center here. But when you flip things up and down, there's no such amplitude, and we're not going to worry about being shifted off horizontally. And I've lost my picture. Let me see if I can get it back. Okay, and then we'll see if I can very quickly. I don't know if you can still hear me. Let's see. All right, we're back. Oh, blasted. All right, we're back. Tangent and cotangent. Graph y equals tangent or cotangent. All right, you don't do one or the other. These are independent. All right, I'll show you straight tangent off the calculator. Y equals clear, clear, tangent x. Graph. Get a series of these S curves. Notice the center one goes right through the origin. That's the usual one we concentrate on. You get an S curve that goes right through here. And there are vertical asymptotes. And you get another one they go forever. And there's one over here, another vertical asymptote, and you get one going through. And the cotangent will be similar. You graph that as 1 divided by tangent. You don't do this and flip things. They look independent. If I tried to graph them over each other, you'd see S-curves going everywhere, just a big mess. All right, and so what happens is these, if you remember, the tangent is sine over cosine. All right. The x-intercepts are where sine is 0. Here, here, here. These vertical asymptotes are going to be where cosine of x equals 0. The 2 center ones are the ones I pay particularly close attention to. If you remember or know, on your circle, okay, your cosine coordinate up here is 0, 1, and the coordinate down here is 0, -1, and your x coordinate is cosine. Cosine. So this is at pi over 2. In other words, a tangent of pi over 2, you're getting y over x, which is 1 over 0, which is undefined. This down here, we're going to use negative pi over 2 because you're backing off the y-axis in the negative direction. Tangent at negative pi over 2 is, again, y over x is -1 over 0 is undefined. So the first ones are period, or pi over 2, and negative pi over 2. One period goes between these. It's the difference. Your period is pi over 2 subtract negative pi over 2, which is in effect pi over 2 add pi over 2, half pi add a half pi, you get pi. And generically then, more general, period is pi divided by k for, off the screen, for tangent and cotangent, not 2 pi over k. That is for sine, cosine, secant, cosecant. 2 pi over k. Period is pi over k for tangent and cotangent. That's the biggest difference. They repeat every pi, not every 2 pi. In other words, they repeat every halfway around the circle, whereas sine, cosine, tangent, sine, cosine, secant, cosecant repeat once around the circle. If you keep that in mind, this is really not hard. Just a quick problem, page 540, 6.4. Try problem 19. Graph. So it's not 3, it's tangent of 3x. Tangent of 3x. I want you to find period. That would be pi over 3. This is the k. Period would be pi over 3. And a graph. X graph. Notice it's a lot tighter. Still goes through the origin. It's just a lot tighter. You really only have to draw the center one. Is the point, which direction? It's kind of an S curve. They call it an S curve. Which direction it is. This is Y, and this is X. We're not really going to make you find the asymptotes. It doesn't ask you to do that. But the important thing is the pi over 3. It's pi over 3 there to there. Cotangent the same way. If we wanted to graph a cotangent, you'd go 1 divided by tangent. If you wanted to graph, just for example, y is cotangent of 3x, your period would still be pi over 3, and you graph it as 1 divided by tangent of 3x. You don't really take this and flip things anywhere, and then it would show you what it's really kind of hard to do. It's really hard to do in your head. So you can do that off the calculator. Otherwise, there isn't a whole lot more to show you. So we will end the Zoom meeting. I've sent around the note that quiz 7 is available now. Quiz 7 is available over 6364 due Sunday the 18th. We will end the meeting and see you next week. Next week, I'm pretty sure we're going to finish up with 6.5 and 6.6 and probably just have the chapter 6 test. One more chapter to go, chapter 7 after that. All right, we will end the meeting.